As we start today, though, it's my privilege to introduce a leader whose vision bridges deep technology and forward-looking economic policy. As Finland's Minister of Economic Affairs, Sakari Puisto brings a unique combination of scientific understanding and strategic insight to the global conversation on quantum innovation. And for your information, he has a PhD in physics, which is certainly well suited for building a quantum economy. Under his leadership, Finland continues to punch well above its weight, advancing quantum research, fostering international collaboration, nurturing a dynamic ecosystem where science and enterprise meet, and from pioneering quantum hardware to supporting startups and sustainable growth, Minister Puisto is helping shape a future where quantum technologies drive both economic resilience and societal progress. So please join me in welcoming Minister Sakari Puisto.
Yeah, thank you and good morning, ladies and gentlemen. We are gathered here today because quantum is no longer just the future, it is here today. It is not only science and technology, but also business, policy and society converging. That is why the Quantum World Congress is so timely. I'm honored to be here with you this morning, and let me express my sincere appreciation for the strong collaboration that Finland has enjoyed with the Quantum World Congresses organized by Connected DMV ever since its very first edition in November 2022. Quantum technologies spanning quantum computing, communication, sensing and materials represent one of the most transformative scientific frontiers of our time. They challenge the boundaries of classical physics and open doors to capabilities once thought impossible. Ultra-secure communications, simulations of highly complex molecular systems, and sensors of extraordinary precision. But quantum is not only a scientific endeavor. It is a strategic one. In today's world, where geopolitical tensions are rising and the global order is being tested, quantum technologies are critical for our economic security. They will underpin future economic competitiveness, cybersecurity and resilience. The nations that lead in quantum will shape the future of cybersecurity, economic competitiveness, and even military deterrence. As countries compete to develop and secure quantum sovereignty, collaboration and research security must remain our guiding principles. Finland is proud to be an active participant in the global quantum ecosystem. We are investing in excellence, fostering collaboration between academia and industry, and building a robust quantum ecosystem. We recognize the importance of working with trusted international partners to ensure that quantum technologies are developed responsibly. We acknowledge the significant contributions of our allies and like-minded countries, including the United States, whose investments and strategic focus have helped elevate quantum to the global stage. In this rapidly evolving landscape, transatlantic cooperation remains vital, not only for advancing research, but for ensuring that quantum technologies are aligned with our values and interests. It is also important that we strive for as big a global market as possible. In times of geopolitical uncertainty, it is more important than ever that we approach quantum development with foresight and unity. We should safeguard openness in science while protecting sensitive technologies. We must build secure supply chains while promoting innovation. And above all, we must ensure that quantum technologies serve peace, prosperity, and the common good. Over the last decade, countries and companies have invested billions of dollars in their quantum programs. Still, success does not always follow directly from the amount of money spent. Science and technology are a little bit like sports. The largest or the richest teams are not always the true game changers. For example, the Finnish quantum computer manufacturer IQM has evolved from a startup to a noteworthy player in the market in just a few years' time. I was especially pleased to note that the B-round funding of 275 million euros for IQM earlier this month. One of our most notable cryogenic device manufacturers, Blueforce, has been in the game for decades, and they have established themselves well here in the United States. Our quantum specialized software companies can help to solve mind-boggling tasks, unleashing the quantum computing capabilities. Finland, despite its small size, now stands among the stronger quantum themes. And as the industry grows, our strengths increasingly span the playing field. From fundamental research to delivering operational quantum computers, providing algorithms and software for demanding simulations and optimization problems, and to key enabling technologies such as cryogenics and laser photonics. I am happy to lead a substantial Finnish quantum delegation packed with all their knowledge here at the QWC, companies which welcome collaboration and seek for new partnering opportunities. Quantum technologies have advanced because countries and researchers have focused on what they do best. In economics, this is known as the theory of comparative advantage. In quantum, it's not just a theory, it works in practice. The Nordic countries are a compelling example of this. In May this year, the Prime Ministers of Denmark, Iceland, Finland, Norway signed a joint statement on quantum collaboration. That declaration builds on the complementary strengths of each nation, and when these strengths are combined skillfully, the whole industry advances faster. The Nordic countries are here at the Quantum World Congress, ready to team up with the like-minded international partners. What then are the decisions that helped Finland to become one of the leading countries in such a groundbreaking field as quantum science? The first part of the answer is quite simple. Though its implementation requires patience, invest in education and basic science. The second part is this: hold on to what you have built and leverage on it. Finland's tradition in low-temperature physics goes back more than 5 decades. Its pioneers perhaps did not imagine quantum computers, but they ensured that extremely low temperatures would be available when needed. For example, when superconductive qubits remain exceptionally cold and stable. Alongside cryogenics, Finland has long studied the fundamental properties of light in photonics, another key area of quantum information science. We also have strengths in advanced materials, microelectronics, quantum algorithms, and more. Is it just a coincidence that Finland excels in more than one or two of these critical fields? To some extent, yes. 50 years ago, there was no such thing as a national quantum strategy, nor even the notion of building a quantum computer with all this expertise. But what we did have was a sustained trust in the value of basic research. Third, provide a favorable environment for fruitful collaboration between research and business to help new technologies crawl out of the laboratory and develop applications for real use cases and high impact in society. When technologies begin to mature, it is time to engage business developers and end users, encourage angel investors and bold entrepreneurs to set up new business, educate the workforce and open markets for new innovations. Finland is now on a promising path in this respect as well. In recent years, we have seen substantial public and private investments in world-class research in the development of commercial quantum solutions, in workforce and researcher education, and in infrastructure. Why does this matter? Because a well-educated workforce, high-quality basic research, and a smoothly functioning research and development ecosystem together accelerate progress and significantly increase the returns of investment. And another essential and critical factor is a vibrant startup culture and a vibrant venture capital and private equity sector. And that brings me to lesson number 4. Science and technology development always involves risks and sometimes rough rides. But within those challenges lie new opportunities. In April this year, we published the National Quantum Strategy, which builds on these experiences and sets ambitious targets for the growth of quantum business and Finland's success in attracting international investments, companies and experts. The main aim is to improve companies' ability to utilize the potential of quantum technologies in developing radical new solutions and strengthen expertise in the sector on a long term. One of the key measures is to ensure conditions for world-class research by creating the world's leading infrastructure for quantum computing and development of quantum devices. With this, we also aim to facilitate cooperation between research and business nationally, but also with like-minded partners. The strategy emphasizes the need for strengthening skills and competence, funding for long-term R&D and innovation, as well as supporting global growth of companies. Our aim is to ensure that Finland can take a prominent role in the development and use of quantum technology in a responsible manner. Quantum information science, a branch of fundamental physics, has been built on international collaboration and the mobility of people. Going back to the days of Albert Einstein, Niels Bohr, and Erwin Schrödinger, and the great American physicist Richard Feynman. Today, quantum companies are reaching a stage where they can offer solutions as off-the-shelf products, at least as far that is possible in a field like this. Does this mean that we already moved from pre-commercial collaboration into a world defined only by competition between companies and nations, each trying to maximize their own profit? I do not believe it is wise to think in those terms. Finland, for example, has leading expertise across a wide spectrum of quantum technologies, but not across the full range. We are not self-sufficient, and I do not believe any country is, especially if the goal is to fully realize what quantum technologies can enable. Of course, in today's geopolitics, there is also a race, and a tough one. And in many ways, it is a race against time. The bottlenecks on the road to commercialize any radical new technology can be overwhelming. In quantum computing, for instance, we must reduce noise, improve error correction, and maintain coherence. Yet we do not have certainty which paths forward will prove the fastest or the most reliable. But we do know that it requires many trials, many errors, and sharing of knowledge among trusted colleagues. And if we want to be among the first to achieve breakthroughs, not alone, but as a winning coalition of like-minded friends, then international collaboration is essential. One of the challenges of quantum that we must also confront at the international level is the change of worldview it may bring. We are moving from the black and white logic of the digital bit, where everything is either a 1 or a 0, to the world of the qubit, with countless shades in between. Some scientists argue that this reflects the true language of nature far better than our earlier, and in some ways cruder understandings. What this ultimately means is still far from clear. Quantum theory is often counterintuitive and offers only limited guidance. Yet we are promised extraordinary new capabilities in sensing, measuring, communication, and computing. Technologies that will be more sensitive, holistic, intuitive, and potentially more intrusive than anything we have known. And they will operate at speeds far beyond today's technologies. While the exact shape of the quantum future is still covered in uncertainty, reasons for both optimism and concern are already apparent. In this respect, the comparison between the atomic age and the quantum age is justified. Like nuclear physics, quantum science transforms our understanding of nature's fundamental forces into immense technological power. And like nuclear physics, it's inherently dual use, with potential for both civilian and military applications. The great challenge, of course, is how to use this power responsibly and how to make sense of the ways it will reshape our world. As Finland's Minister of Economic Affairs, I'm proud to see researchers and companies from Finland helping make sense of this transformation and influencing its future direction. I'm equally proud and content to see them doing so alongside colleagues from other nations, each contributing their own unique strengths here at the Quantum World Congress. Conferences and networks like this one are vital. They ensure that we face the quantum transformation not in isolation, but as a community of trusted partners who value open science by also recognizing the need to protect its achievements. Only in this way can we ensure that if we move fast, we do so in the right and sustainable ways. With these words, I warmly welcome you to the third and final day of the Quantum World Congress of 2025. I wish you all an excellent and productive conference. Thank you very much.